And these are the characteristics of the data warehouse. It's a subject-oriented and integrated, non-volatile and time-variant. What is subject-oriented? The data stores, data warehouse or design it to help you to analyze our data. For example, the same which I discussed just now. So it is related to different subjects. Say suppose we must have a sales fact, inventory fact, purchase order fact. So what a sales fact contains? Sales fact contains the sales related information with the measures. And the same way, and the inventory data contains the inventory related information with the measures. So it's related to different subject areas. That is one of the characteristics which is subject oriented. And integrated. Integrated is also close to subject orientation. Data warehouse data, it's in a consistent format. Whereas in a YLTP systems, we don't have that much consistency in a normal databases. Like people enter the data from the POS. We know what is POS, POS, point of sale. People enters into the data and stores into a database. Maybe that is not a inconsistent format. We clean the data. We transform the data into a consistent format. And non-volatile. Okay, I'll go with example here. Let's see what is non-volatile. Once the data entered into a warehouse, the data should not change. This is a logical. Okay, once the data entered into a data warehouse, that should not change. Okay, we'll see why it should not change and what is time variant. The data in the data warehouse, since we also maintain the history and we also maintain the years of data at certain time. At certain time, we will get some updates. At that time, the data should have to update. In such cases, the data in the data warehouse will update on a particular. 1 second, please. Give me some time. Sorry, guys. Okay, it was running. Okay. So we'll see an example for all these three characteristics. Oh, let me show you how the data in data warehouse is a non-volatile and how the data in data warehouse is a time variant. Okay, let's consider an employee table. Employee ID, employee name, date of joining, so we have these columns. Give the employee ID as 1001 and name as David, and date of joining is 01/01/2016. Okay. And the salary consider as $1,000. Okay. So this is our employee table. Okay, let's consider I have only one record in the employee table. Let me take one more record. 1002. This is Alex, and his joining date is 01/01/2017, and his salary is $2,000. Okay. Okay. Now this is my employee dimensional table where I have a employee name, employee number, data of joining, and salary. And this is the key column. Consider employee ID is a key column. Then how can you say I will get an update like since David joined a year ago and he got a hike in his salary, and the salary revised to $1,500. Okay. Now, how can we update this data without changing the without changing this? How can we update the data without affecting a record? And we should follow the characteristics of non-volatile or a time variant as well. So for that, how we do it in a data warehouse. Employee ID, employee name, and date of joining, salary, and we have three more columns called effective date and expiry date and status. Okay. So the first column is, as usually we have here in our dimensional tables. And the effective date is the date of joining when he will join, the 01/01/2016, and the expiry date would be infinite date that we can select it as 11/31. So, here the date format is DDMM by 31/12/999, and the status is active. Okay, this is how we maintain the data in a data warehouse. When he got a revised hike in revised salary, and that record we receive a record like this, incremental data. We'll receive update record of this, and the same will be inserted without affecting the already existing record, which is a history. 1001 David, and date of joining is again 01/01/2016, and the salary is 1,500. And since when this change is effective, that is the effective date. That means it's current date. Say he got a revised hike on this current date, then the date would be 19/03/2017, and this record expires on infinite date, 31/12/2000, and this is the updated record. And as well as we will update, this is the record we insert now, and we will update the old record, history record, as effective date the same and expires on today's. And the status is I, which is in. So, and you could ask me one thing. This is the employee ID, and there it is a key column, and you can select it when you. Yes, please.
Sham, this is Angel. What is I? Your voice is not clear in that. What is I? The status.
The expiry date should be
The state I is
2017.
What is I?
sorry, it is 2017. What is I stands for inactive? Either it's a user, you
Inactive.
can choose anything inactive.
Okay.
So the data is inactive. So and you could, when you try to retrieve an employee David, you can see a two records. So this is data redundancy. So we have a two records for a one value. To avoid that, in a data warehouse, we introduce we have a concept called surrogate key. So while inserting the data, we'll generate a surrogate key so that the data in the data warehouse is unique. Like this could be a 4, 5, 6. Surrogate key is nothing but a sequence number that generates top of the records. Okay, now this is a unique record. This is a unique key. Surrogate key is just a unique key. It's not a prime. It acts as a primary key in data warehouse, but it is just a unique key. So this is how your data stores in a data warehouse, and there is no loss to your history, no loss to your history data, and you inserted one more data which is in a status of revised record. So any doubts in this concept?
Hi Sham, this is Angelan. I just have a doubt. Like employee ID is a primary key, right? Or while creating a table itself, we'll give that as a primary key. So in the primary key, even if you try to insert a record with the same key value, it will not allow you to insert a record. It will say key constraint. It will say the keys already exist, right? How will it is possible in data warehouse by having the same value in the primary key column?
In a data warehouse, open in a
Sham,
data
your
warehouse,
voice is not
we won't
so
define a
clear.
primary key actually.
Sham, your voice is not clear. Like getting bit by bit voice. Hello.
Oh, I'm sorry. Now can you hear me clearly? Is it clear
Yeah,
now?
yeah. Yeah, it is
Angela,
audible
is
now.
it clear now?
Yeah.
Let me show you a table.
Uh-huh.
Let me show you a table. How we
Sure.
design tables in a data warehouse.
Sham, meanwhile, one more question. You said one word called dimensional. Dimensional table, right? Hello.
Yes,
Hello.
dimensional tables.
Dimension. What is
Yes,
dimensional
dimensional
table?
table. Angela. Yes,
Yeah, what is
I'll come
dimensional?
to dimension.
Okay. Okay. Sure.
Dimension. In my project, we are using a NetEase as a database. So I'll show you how the how we define the tables in a data warehouse. Just give this. Sorry, I was muted just because there was a huge noise. Okay. Okay, let's take this table. in this table, nowhere I defined a primary key. In a data warehouse, we don't define a primary key. We'll just since in my project we have not defined the primary keys. It acts as a primary key since it is employee number. We apply it as a key column in a data stage. Let me show you that. See, in an it is a we just define this is the table name. This is the table, and these are the columns. And in it is the data will be distributed on the into the partitions. So we distributed it is on a random partition. Okay, how we define this column? Okay. Let's see, open this job. You can see here. Okay. Here we defined let me open the carrier job. It's the other job. So I'm extracting the data from the database here. And these are the columns I have. Here I defined carrier dimension ID is a key column. That's it. We don't do a primary, we don't have a primary key or a foreign key things, but we consider that as a key column. This is the key column. And this key column, we use this key column in while loading the data from the dimensions to facts at a fact level. Okay, what is dimensional table and what is Angelina asked what is dimensional table and what is fact table. Dimensional table contains a key column with detailed information of a subject. Okay, what is that? See, you could see. Let me select one thing. See, you can see here. As I told you, we have a surrogate key. This is the key. In our project, we defined it as an item underscore sequence ID, which is SID. And this is the unique value of this item number. And this is the item code. And this is the item description. And this is item long description. Like this, we have all these detailed information of that particular item and what is that particular line number. And so there are details of the item weight and its capacity. So it belongs to this is the company. It means this is actually we are in a manufactured domain. So this is the company where that item manufactured. And this is the created date and the change date when the data is inserted into, which I told you effective date and expiry date will be like this. Okay, So this is how we store the data in a data warehouse, which is a summarized information, sorry, detailed information of a table. A table having the key columns with a detailed information. We called it as a dimensional table in a data warehouse. Any doubts, Angeline?
Unmuted.
Any doubts in the dimensional concept?
No, I'm clear, Asha.
Yes.
Can you show an example of a fact table?
Yes. Then the next thing that I'll say my
Muted.
okay. Fact table. Okay, here you have seen this dimensional table, item dimension. Okay, let me open our sales table. This is the sales order is the fact sales order table. We'll limit to 10. We'll try to get 10 records. Okay. Before going to that, we'll show you how the fact tables designs. We'll go one by one. And this is the data warehouse architecture, and we have a data sources, which may be operational system and the flat files. We'll extract this data into a data warehouse staging area. From there, we'll apply the business logics and transformations, and then we load the data into a data marts, and then from the data marts, the data will be accessed by the users according to the respective subject areas. Okay. Yes. So to design a data warehouse, we need a schemas. Schema is a collection of data tables and its objects, database objects. So we have majorly we have two types of schemas. One is a star schema and a Snowflake schema. How does star schema will be designed? See this. See, I have the definition of a star schema is a fact table surrounded by denormalized dimensional tables. We may have aware of this normalization process. So denormalized tables may cause for data redundancy. So this is a simple schema. Here I have 4-dimensional tables. I have a fact table and surrounded by a 4-dimensional tables. For our easy understanding, I have given store ID is a key column, and I have this is a sales fact, and I have a store dimension which has a store ID and its address. Let me show you. Explain this. Okay. Say I have a store dimension, and it has a store ID and store name, and other dimension I have is product, and in this we have a product ID and product name. Okay, etc. And next one is a customer table, and here we have a customer ID and customer name. And here I have a salesman. We may be an employee also. who sells the who. Here the employee is the same, like in a store we have our employees and the salesmen, both are same. Let me consider it as a salesman table. Salesman ID and salesman name. Okay. Now we'll design a sales fact. Okay. Now what I need is who is that salesman. Now I need this salesman ID and customer ID and product ID and store ID. All these are the columns from the dimensional tables, acts as a foreign key in sales fact. And here, how many products, how many product name, how many units were sold, total units, and cost. This I retrieved from the units from the product table, and I'll calculate each price, product price, and total price, and tax amount, or something like. You can see all these are the information from the dimensional tables, and we will calculate the measures here, the total units or a product price or a total price and taxable amount. This is how we design a fact table from the dimensional tables. Let's see an example for the same. Okay, here I have an employee sequence ID. See, I have given salesman ID. In a dimensional table, as I told you, we have a key. We generate a surrogate key. We use that surrogate key, and that should be a unique key here in a fact table. And item sequence ID, and the logistic company, and its finance company, warehouse, unit of measure, like this. We'll have the key columns, and we'll calculate the amount. See this order quantity, and local, this what you may ask, LC sales order line amount. What is this? Local currency. So initially, say since our project, our organization is in a multiple companies, multiple countries. Say suppose from China, he want to see only a China data. So while doing that, he want to see the amount in his local currency. So we, in a table, we will pass this as a local currency. But while generating the report, we will in the views, we will convert that local currency to USDs. See, this is the same. And over here, the global currency we choose as a USDs, local currency value, line number, and global currency. You can see this global currency, tax amount, and discounts which we have given. So this all you can see majorly, you can see only measures, which are the facts. So we call it as a fact table. So this is the order quantity, open sales order quantity, and cancelled quantity, order amount. You can see here we have not loaded the global open order amount. We have only a local currency open order amount. We have this column here, but we'll populate this column through a view in the report. And this is the employee order created by, this employee code, employee short name, and you can see this internal sales rep code. He is the salesman rep, he is the sales manager, and you can see his names, and this is the company, and this belongs to Malaysia. And you can see employee dimension ID also here. So like this, we load the data into our fact tables. So you can ask how we load. Okay, I'll show you. We'll see the job also. Okay. This is the source. Our source is Oracle, so I'm extracting the data from the Oracle connector. Using the Oracle connector, and we connect to Oracle database, source database, and extract the data. See here, I use a lookup dimensional item and employee dimension, company dimension, sales type dimension, and warehouse, UOM, business partners, finance companies. All these data, from all this, I joined this data and extracted the dimensional data and loaded into a fact table.
Unmuted.
You understand? Yes, yes.
What was that? What was
Yes,
that
please.
funnel you perform in the diagram? That what was that
Yeah,
funnel?
we'll discuss one by one. So now we'll discuss it. The funnel is a stage where you use the combine the data. So this, okay, see, let me explain you. This is my sales orders table, and this is my cancelled sales orders. So I want to combine both the data. It's not a join, please confuse. It's not a join. I want to combine both the data while extracting from the source itself. So I have used funnel stage here to combine both the data. That's it. Hope you understand.
Yep.
Shyam,
Yes, please.
can I go ahead? Yeah. Shyam, you said about the properties of data warehouse, right? Non-volatile, time constraint, integrated, and subject-oriented. So you were about to start to show why it should be non-volatile. So you have completed that part?
Yes, I have completed. You want me to repeat it again?
No. So you said it is non-volatile, right? That means once you enter the data, it should not be updated. That is non-volatile, right?
Yes. So this is what this is the data. It's a history data, and this is the data. It is not updated. We have just updated the effective date and expiry dates. And this is the characteristics of a non-volatile and time variant, where the data is also, when we got an update record or incremental data, then I loaded it as a new record. So I have not disturbed my existing data. So this is time variant.
Okay. So the integrated is like consistent manner the data is stored, like related data is stored in a consistent manner.
Yes, and the subject area, Let me show you. I'll have a see in the diagram itself. We can see it. Yes, sure. We'll share the PPT. I'll email the PPT to IntelliPart. They will share the PPT with you. So you can see here. Once the data is loaded into a data warehouse, there is a two approaches to load the data into data warehouse: bottom-up approach and top-down approach. Here, top-down approach, which means once we load the we extract the data, and then we transform the data, and we load the data into data warehouse first. From the data warehouse,
Muted.
from the data warehouse, I load the data into a different data marts. Data marts. Data marts is nothing but it contains tables of related informations. I have a sales data mart, I have a inventory data mart, I have a purchase order data mart, and I have a pocket. I mean, we have a different data marts like account receivables and account payables to different data marts. And this is the top-down approach, and we have a bottom-up approach. What is this bottom-up approach? First, we'll extract the data and transform the data, and we load then into a data marts. From the data marts, I load into a data warehouse. Why we want to have these data mart? Why we want to load the data into a data marts first? Okay, in a retail or in a banking systems, the users are nothing but executives. They want to see their data first by their early morning. So to make it fast, I load the data into a data mart first, and from here I start generating the. Let me show you in the diagram. From the data marts itself, I start reporting or publishing the reports in a web. And then leisurely I load the data into my data warehouse, which is the final data warehouse. These are the two approaches we have, and mostly we follow the top-down approach. In some cases, we'll follow this bottom-up approach. So this is the same. You can see this is the top-down approach. Once the data is loaded into a data warehouse, then the data is we are loading into a different data marts. From the data marts, the users are accessing, or we publish the data into a web.
Unmuted.
Any doubts as of now?
Yeah. So all the values from the dimension table will not get into the data warehouse. Is that right?
We collect the data based on our requirement. It's not a thing that it's mandatory to have all the columns from the dimensional tables into a fact table. It's depend on the user requirement. If user wants to have all the columns, it's we should pull all the columns.
Okay.
Yes, Angelina, you are talking. You are asking something.
No, in reality, which approach majorly they are using, bottom up or top down?
It depends upon the domain. When the banking or in a retail, people use this bottom-up approach. In a
Okay.
manufacture, since in the manufacture it is not, they have a weekly reviews, and what they do, they'll weekly review their plants. So it is not it is uh, it's based on their
Uh,
requirements.
okay.
And the
And
surrogate keys, are they generated from the system, or we have to
we
get
have a
SQL?
you have a two types. So we can generate from the system, or you can give a standard value in a file, and you can load that file. You can try to, you can, in the job, when you pass this file, the surrogate key will generate it based on that standard values.
Okay.
And we haven't gone through Snowflake schema, and this is a Snowflake schema, which means, okay. See, in the product, I have divided this again into a subproduct. So in this case, I may have minimal choice to get the duplicate records. So this is the same concept. The fact table surrounded by a normalized dimensional tables. So how you get this normalized dimensional tables? To divide your dimensional tables while loading itself, I'll like this. I have a product. So in simple way, I'll tell you. Say suppose I have a sales order. Say suppose I have a sales order. To this sales order, we may have a sales order line numbers. Sorry. What is sales order is like 10001, and line number is 1, and again line number is 2, and again line number is 3. And you may have also a sales order description. Open sales order, it's a closed sales order, and this is the returned, or it is a cancelled, like this. See, if you don't choose this sales order number, this and a sales order description, if you choose only a sales order, there are chances of getting duplicates. See, when you select only a select star from table, sorry, select a sales order from table, then it gives us 3 values, and both 3 are same. In such case, when you have this thing, select sales order from a sales order line number, then it gives a different values, and those 3 are not same. So this is the benefit of Snowflake schema. In real-time systems, mostly people use the Snowflake schema. Even you can see this here. I have a sales order. See, I have a sales order number, and I have a sales order, position number. Let me retry this. See, for the same sales order, I have two entries, and the sales order position number is different. Hope you understand.